this morning, afternoon, depending on where you're from. Container apps with amazing speaker and definitely someone who knows the stuff in the field as well. I think you've done a course on it as well, but I'm sure you can talk to that when you get there. So for those of you watching the recording or dialing in, this is just part of the Microsoft Learning Room community. So we've got learning rooms where people can go and register. They get invited to a Microsoft Teams tenancy, and we help students answer questions and help them with their study and have sessions like this. So putting it on today, this morning. For those attending this call, this session will be recorded. So if you don't consent to being recorded, please disconnect your line. Attendee names are hidden on the recording, but if you speak or ask questions, which I encourage you to do, just be aware of that. Just like most sessions that we do, it's very inclusive. We've got a mix of people in the room through different nationalities, different area. Like today we're talking about Azure container apps. There might be people already working with this for the last couple of years, and there might be people in the room that's only heard of it today. So just be welcoming, respectful, be kind and considerate. Feel free to use the chat, ask questions. I'll help moderate there. And yeah, just have fun and learn. So yeah, over to you. Thank you for coming and presenting.
Yeah. Thank you, Luke, for this introduction. So to introduce myself, I'm Houssem Dellai, working in Microsoft as CSA. CSA stands for Cloud Solution Architect. So our work is to help our customers to be successful learning and using Azure. So we help them in their production systems and their architecting and their testing and their poking for Azure. And today my presentation will be about Azure Container Apps, the almost new service that today Azure Container Apps is like 2 years ago was introduced in Azure services. So I'll give a brief introduction to this service, okay, for the people who don't know it yet, and then I'll move for I'll give also a demonstration how to create new container apps, how to work with it using the Azure portal and also from the command line. So as Luke mentioned, don't hesitate to ask questions, raise your hand. This presentation would be delivered better if it's interactive and if you ask questions, so don't hesitate. I start my presentation by presenting why we did need Azure Container Apps. So before Azure Container Apps, we have multiple Azure services that could run containers, okay? So we have Azure Functions that can also run containers. We have Azure App Service, which part of it can run Docker containers. And we have Container Instance, which is one of the oldest solutions in Azure for running containers. And at the other hand, we have also Kubernetes service, AKS, which is the most known orchestrator or the most known solution for running containers in the world today. We can say that. We have also some other services like Service Fabric, and you can also use raw virtual machines in order to deploy your containers on. But there is a major difference between all of these services. So going from the left to the right, to the left, you have the services that requires lots of infrastructure knowledge. So to maintain virtual machines, to maintain an AKS cluster, you need to have a minimum of infrastructure knowledge. And that knowledge, for some people who are, for example, for the developers, they don't have that infrastructure knowledge. So they want to use another service that is made for them, made for developers, a service that would be easy for them to create and to manage. Those services are the services on the right of the screen. So Basically, you would have here app service, which is one of our most known services for developers. It's known for its simplicity, it's configurable, it have lots of features and lots of options for customization. But we have also functions, okay? So, and we, we saw that there is a sort of a bridge or sort of, a gap between those two services, the services that are more oriented infrastructure and the services that are more oriented developer. So we needed something between to fill that gap. And this solution actually, as we'll discover today, is going to be Azure Container Apps. So Azure Container Apps will be in between. So it will take both the advantages of infrastructure-based solutions like AKS. Infrastructure-based solutions are a little bit difficult to manage, but they offer lots and lots of flexibility and lots of options. With AKS, you can customize your workloads, you can customize the VMs, you can customize how you deploy the application, you can customize your DevOps pipelines. So you have lots of options. On the other hand, with platforms like App Service, it's easier to use for the developers, but it have less options than AKS. So we need something between the two. And this was Azure Container Apps. So it will take both advantages of the power of AKS and also the ease of use for Azure App Services. So what is Azure Container Apps? It's the new offering in Azure. New, when I say new, it's 2 years ago. So Azure Container Apps, it will enable the executing application code packaged in any container without managing any infrastructure. So that's the premise of Container Apps. You have your container. So as the developer, you will write the application code, but you will also create the container, the Docker container using the Docker file. So your output as a developer will be that container. Now, when you worry and when you ask, where do I deploy that container? So here you will consider those many solutions. And here, container apps will be, let's say, the easiest solution for a developer background team. So container apps is actually is based on Kubernetes itself. So we can say that today, but it might change in the future. So behind the scenes, we don't see that AKS cluster, but for today it is, and this might change in the future. So I repeat it again and keep that in mind, because in many presentations you will see them telling you that AKS is empowering container apps, but this might change at any time. However, what will not change is that behind the scenes, Container Apps is also composed of Dapper, which is the distributed application runtime, and KEDA, which is the Kubernetes event-driven autoscaler. Okay, those two components will offer more options and more features to the container apps. Those features are typically needed and used by the developers, okay, to make it easy to develop their microservices and to scale their applications. We'll explore those two tools later in more details. So yeah, so at the end, to resume, Azure Container Apps will have the benefits of running containers easily without maintaining a complex infrastructure. We can consider it as a serverless solution because it can scale to 0. It means that at this time, when it's up to 0, this means that there are no infrastructure behind and we don't pay during that time. So this could be good for optimizing the cost of our applications. And then support the multiple scale and scale out features. So it can scale based on HTTP requests, it can scale based on events like number of messages within a service bus, for example, and a lot more. So Container Apps is built on top of AKS, SCADA, Dapper, and also Envoy. We didn't mention this one, but because with container apps, we go to expose our applications to the internet or internally within the private network. So to expose those applications, we'll go through Envoy. Okay, for people who are familiar with AKS, we typically use an ingress controller to expose our applications in Kubernetes. We do the same with container apps. We use Envoy, which is a reverse proxy solution that is used in order to expose the services on the internet. So when to use Azure Container Apps. So there are 4 different use cases for container apps. So first one is traffic splitting. Okay. So this is one of the major features in container apps. So when you are developing an application, typically during each sprint, you would have a new release. Okay. So let's say the current release is the one that is running in production, and then the next release, you will add more features. And before releasing that release into production, you want to test it. Okay. So, okay, you will test it in dev, test, and QA environments. But even with this, all of these environments, you might still have issues when deploying to production. So what container apps allow you to do here is that it's kind of testing inside the production environment. So you will be allowed to deploy your pre-release version into the production environment, and then you can send like 20% of the traffic to the new version. And then you will be watching, of course, through metrics and so on, if that new version is behaving correctly and if it works correctly. If that's the case, then you will switch up to 50%, then 80%, then 100% of the traffic will go through the new application, and then you decommission and you remove the old version. We can do this in Kubernetes, actually, in AKS, but it requires that you install other and additional tools, and there are lots of configuration to do. In container apps, it's out of the box available there. You don't need to enable anything to get it. A second use case for Azure Container Apps is the background processing. So let's say, for example, you have batches or jobs that you want to run, and those batches, they will be triggered with an event, external event. They will run during a certain time, and then they will stop. Okay. So the best way to do it, you can do it as a web application, but we have the feature called job, which will allow you to run it as part of a job. This means that when that trigger starts, it will provision the new instance. It will run its execution. For example, it will analyze some PDF data, or it will write reporting, it will generate reports from a database and so on. And when it ends that processing, the job will stop running. Okay, and during that time, you are saving money. So that's the background processing. Third use case is event-driven processing. And this means that we'll be able to trigger the application, the container apps, based on an external event. Let's say, for example, we have a queue for processing messages. Each time we have a new message in that queue, I want to trigger a new container apps to run. Okay, so we can easily configure such a configuration. And the fourth use case is, of course, microservices. So during the in the beginning of my presentation, I have presented Kubernetes, AKS, as a powerful solution where you can deploy almost any kind of architecture you want. You can deploy microservices and so on. And you have presented also Azure App Service. With App Service, the limitation we have today is that you cannot deploy all the microservices within one single instance of Azure Container of App Service. So in App Service, you can deploy one single application. Okay, so it means that if you have 10 microservices, then you will need to deploy it into 10 app services. Okay, this is not the case with container apps. With container apps, you still have one Azure Container Apps instance, and inside that instance, you can deploy multiple applications or multiple microservices. The advantage of having all of these microservices within the same container apps is it becomes easier to manage, to governance, to secure, and so on. And for the microservices, as we mentioned earlier, we can leverage Dapper and Keda in order to auto-scale and also to provide features that will make it easier to develop microservices. I see a question in the chat. When would you use container apps over AKS Automatic? Yes, so AKS Automatic is different than AKS. We have released this new offering in Azure a few weeks ago. And the aim of AKS Automatic is to make AKS a little bit easier for developers. Okay. And we said that container apps is the service that should be used by developers. So it's like we have two services that are in direct competition, that competes with each other. This might be true, but still container apps is more, it's built from the ground up to be developer oriented. AKS Automatic is, you still need to learn and to master a little bit of infrastructure, even if it's easier than managing a standard AKS cluster. Okay, so if you are a developer, you don't want you don't want to manage any infrastructure. It's container apps. If you want to get a little bit access to the Kubernetes cluster, to the objects of the cluster. If you want to be able to deploy anything to your AKS cluster, then it's AKS. Okay. Yeah, so it depends also on whether you need to get access to the Kubernetes API or not. Because with container apps, even if today there is an AKS cluster, you don't have access to that AKS cluster. You don't have access to the control plane. You cannot do kube control command line on container apps. However, you can do that with AKS Automatic. Okay, and that allows you to deploy custom resources, to customize more your application, to deploy operators, to deploy almost any tool and any feature into your cluster. Okay, so let's move next to the features of Azure Container Apps. So let's explain the features and also the structure of an Azure Container Apps. So we have 4 or 5 components of Azure Container Apps. First of all, we have the environment. So when we create a container apps, first of all, the environment should be created. The environment is an abstraction over the infrastructure that will be running the container apps. Okay. So you can see it this way. You have your environment inside of which you can deploy multiple applications. Okay, so you can look at this as, you can see this as let's say not a namespace, but like your Kubernetes cluster, inside of which you can create multiple namespaces or multiple deployments. After creating the environment, you will be creating the container apps itself. Okay, so for this to make the distinction between environment and container apps. So the container apps, it's where you deploy your containers. Each time you have a new application, you deploy it into its own container app. So you create a container app per application. If you have microservices, each microservice will live into its own container app. And then inside the container app, we can deploy typically one revision, but you can have two or multiple revisions. Remember, the revision is what allows you to send 80% of the traffic to one version, and the rest of the traffic will go to the V2 version, for example. And then inside the revision, we'll be deploying the containers, which are the output of the for the developers. So when you deploy your containers, you specify in which environment, in which container app, and in which revision. So by default, you don't specify the revision, and container apps will create a default revision for you. But if you want to create a second revision, then you should give a name or you should specify that it should be a second revision to not override the existing revision. Okay. So with Azure Container Apps, the objective is to deploy and expose our applications over the internet or privately within the organization. And for this, here we are talking about exposing the applications. And the typical Azure service for exposing applications is API management, which is another service in Azure that will allow you to secure your applications and to manage who can access your application, who can see it, who can change the applications, how you expose it, how you can give access to the developers, and so on. So that's we have container apps that could be integrated with API management. It means that you deploy your container apps privately. It will be private, so no one will have access to it, and then you expose it publicly through API management for a better security. So the revisions, we have mentioned that this is what will allow you to send like 80% of the traffic to pod 1 and 20% to the second revision. And I'll share the slides with you, so this contains more data for the ones who want to get more details about these. And this is how you can create a new revision within the Azure portal. So typically within your application, you will go to say, hey, I want to create a new revision. You give it a name like V2, for example, and then you specify your container, and this should be your newest container. And then from the portal also, you can choose how much or how much traffic to send to the V1 and how much traffic to send to the V2, for example. And you can change this at any time you want. I skipped some slides just because they contain lots of information for the ones that want to get more details. And I'll skip to container app jobs because I think this is very interesting and very important. Container apps jobs will help you to run containerized tasks. Anything that is a task, job, batch should run inside the job. So within container apps environment, we can deploy either a container app or a job. Container app is typically used for web applications. We want to keep our web application running 24/24, 7 days on 7. Okay, so for that we choose the type container app. And we have some other applications or some other workloads that don't need to be running on 24/24, like for example the batches and the jobs. For that we create a container app job. Okay, so this will be triggered, it will run for a certain time, and then it will stop, and that's all. Okay, it will be finished. So those jobs could be triggered either manually. Okay, so you say here, I want just to click on a button to trigger it. Today you can do that from the command line, or you can also trigger it based on a schedule. So you say this trigger will run each each midnight because I want to generate some reports out of my databases. Okay, and it could be also triggered based on an external message event or based on events. Here in this print screen, I'm presenting. So from here, you can see already the difference between container app and container app job. And the way to create it is the same way you create a container app. You specify a name and then a resource group. And you say then start for that job. And of course, you always specify your Docker image from here, and you choose the trigger type to be either manual or event or automated. Yes, I see a command saying that I've used Azure Container Apps jobs for ADO, for Azure DevOps self-managed hosts, build agents. Yes, that's one use case. One typical use case for using container apps jobs is that you can use it to run the build agents in Azure DevOps, or what we call the runners in GitLab or in GitHub. Those are the machines, or those are the machines that will run when we want to trigger a CI/CD pipeline. So remember, when we trigger the CI/CD pipeline, it's only at that time we need a process to run the pipeline. Okay, so the container apps can run that pipeline, and at the end it will just exit and it will stop running until we have a new run for the pipeline. Then a new container app job will be created and do that. So it's good for anything that just starts, do processing, and then stop its processing. Yes, so for container apps, we need, because those are a service that is developer oriented, and developers works a lot with logs. That's the way to get to understand their application and to debug and troubleshoot their applications. So container apps, of course, supports logs. So you can see the logs from your container apps from the log window here, where those logs are typically saved into an Azure Log Analytics instance. And Azure Log Analytics is the service where you can store your application or system logs. So it's anything. It's service for saving anything log. Okay. And for logs, we have two types of logs. Okay, so we have container console logs and we have system logs. Container console logs are the logs coming from your application. So when your application starts, it will create, or it will write logs to the default output. Okay. In addition to that, you'd have also the system logs. The system logs are not application logs, but those are the logs from the platform itself, from the infrastructure platform. So container apps, at the end, it's a server that will run your application. System logs means that those are the logs coming from the server. Okay, so you can see when that server started running, if it's running your application or not, if a crash happened inside that server. If you are mounting a volume, you can see that in the system logs. If you are using revisions, traffic splitting, domain names, you can see their logs from system logs. Okay. Okay, so I think that's enough presentations. I still have some other slides, but I think here I will skip to a presentation, or to a demonstration, sorry. So I'll switch to the Azure portal. And from here, as you can see, I have already created the container apps and container apps environment, but I'll go through another demonstration to show you how we can create a new container apps using the Azure portal, which should be the easiest way to create a container app or to create any Azure service. So from the Azure portal, I go to search for container apps, and note here I get this icon saying container apps. If I make this bigger here, I go to create a new container apps. Let's do that. So for creating a new resource in Azure, you will need here to specify your own subscription and then specify a resource group. For this demonstration, I'll use a new resource group. Let's call it RG Demo Azure Container Apps. ACA stands for Azure Container Apps. Okay. And then I'll give a name to my container apps. Let's call it Demo ACA. And then we specify here either container image or source code or artifact. So the input of container apps could be just give me your Docker image, okay? Or give me the Docker file and the source code, and then container apps can build that image for you. So either you build your image and give it to container apps, or you just give the source code to container apps and it will build it and host it there and run the application immediately. In this example, I'll continue with the container image, okay, that is available in a container registry like Docker or Azure Container Registry ACR. And then here, it's asking me where you want to deploy your container app. So I can deploy it to an existing instance of container app environment, or I can also create a new environment. And that's what I'm going to do here for this demonstration. I'll go to create a new container app environment. Okay. So let's give a name to our environment. Let's call this one environment demo, for example. And then here we have two options to choose between workload profiles or consumption only. Workload profiles, consumption only is the, let's say, the serverless mode. So Azure will provision virtual machines for you. You use it and it will auto scale automatically for you, but you don't choose what kind of virtual machines. Okay, by default, I think it's the D4, but you cannot change it. With workload profiles, this gives you more flexibility to choose which kind of virtual machines. This is important. Why? Some applications will you have different properties. Some applications uses lots of memory than CPU. Some other applications uses more CPU than memory, and some applications will require to use a GPU, graphical processing unit, for applications that uses machine learning or that exposes LLM, large language models, and so on. So each application is different and it have different requirements. When they have those different requirements, this means that they will need different requirements in terms of infrastructure. And this flexibility will be offered by workload profiles, where you can choose the type of virtual machines. In Azure, we have like hundreds, like 600 or 700 virtual machine with different CPU capacity, different memory capacity, GPU capacity, different, let's say, they are different also in terms of disk, the type of the disk you can attach, and so on. So with workload profiles, we give you this flexibility. You cannot choose from the 600 virtual machines, but we have made a selection for you of some specific virtual machines that you can use. We'll see this in the next section right here. Let's continue with the next configuration here, which is zone redundancy. Zone redundancy means that here Azure is asking you whether you want to run your containers in one availability zone or in multiple availability zones. What is an availability zone? So when you have an Azure data center, Azure data centers are across almost all the world. Okay, they are present on more than 60-ish locations in the world, and in each location, we don't have one single data center. So in New Zealand, I think we have already a region there, or in Australia. So in those regions, we don't have one single data center. It's multiple data centers. And those multiple data centers are available in what we call availability zones. Typically, there are one or two or three availability zones, and there are a distance between those availability zones to make sure that if one availability zone go down, then the rest of the availability zones can continue running your applications. So this gives you more flexibility to run your applications when you have a disaster, for example. So Container Apps offers that feature to offer more available and more redundant solutions. If I move next to the configuration for the workload profiles, here we mentioned it, this will give me the option to choose which kind of virtual machine I want to use. So let's say this is demo profile, give it a name, and then if I choose a size, here I will see the different VMs offered and as part of this. So here in this region, we have either the general purpose D series virtual machines or the optimized E series virtual machines. We can see the difference here is the ratio between number of CPU to number to amount of RAM. So this is ratio 1:4. This is ratio 1:8. Okay, and depending on your application requirements, you choose the one or the other. I continue with dedicated D4, and you note here, of course, the price will also change from one configuration to the other. I'll continue with dedicated D4, and then here I see how much that's gonna cost me per month, 224, and then here I configure the auto scaling. So we have mentioned that Container Apps will make it easier for you to auto scale thanks to using KEDA. But KEDA is only used for auto scaling based on number of containers. But we have also auto scaling for the infrastructure side, because when your containers auto scales, at some time they will hit the limit of the available current infrastructure. So for that, the infrastructure also, the virtual machines needs to auto-scale. And that's what you can configure in Azure Container Apps. So from here, you can choose the minimum and maximum number of virtual machines and let Container Apps decide which should be the right size of your Container Apps environment, the number of VMs. So 3 to 5 here, this is the number of instances of these virtual machines. I'll just make it from 2 to 5, and not here I get a warning saying that 3 is the recommended, because I'm using availability zones, 3 availability zones, so it means better to have 3. Okay, I'll continue with 3, and then I'll move to say here add, and then I'll go to the next section, which is monitoring. As we said, with Container Apps, you will get the logs from your application, and here where you can configure that. So you can save the logs into a log analytics, or just don't save it, or just send it to Azure Monitor. And then from here, you can create a new instance of log analytics, or let Container Apps create a new instance for you. Just to explore the last option here, networking, which is very important also. This is in terms of you should here where you should decide whether you want to expose your application either publicly on the internet for your users, maybe they are in different countries, or you want to expose your application for your only for your employees inside your organization, or you want to expose the application between an API management or behind an API management or behind an application gateway. And you can also choose to host your container apps into a subnet or a virtual network, so that you get more control over which other Azure service can access that container apps, and which services also that could be accessible by container apps. So for example, if you have an internal database, or if you have a private database into Azure, and that database is only accessible from Azure, it means here you will need to deploy your container apps inside the same network that is called virtual network or VNet in Azure as your database, so that your container apps can communicate securely and privately to your database in Azure. So you have multiple options here. I'll continue with no just for simplicity, and then I'll go to say create. And then I'll move here to the rest of the configuration. So I'll go next to container. And this is also important, where here we should choose which container to run inside this container apps. So here you have two options. You can bring your own container, of course. So here we'll ask you, so typically for, let's say for most or for almost all the container services, they will require or they will get the Docker image from a registry, from a Docker registry. That could be either Docker Hub or Azure Container Registry or GitHub Container Registry. There are multiple registries available there. So typically we get the image from a registry. So this means that the developer should, when he creates his Docker image, he will deploy it into a registry, and then container apps will get that image from a registry. So here we need to specify which kind of registry. That could be ACR or Docker Hub or other registries. Then you should specify that registry will be protected, so through with the login and password. So container apps will need to get those username and password in order to access there. For simplicity here, I continue with quick start image. This means that container apps will get the image that is called simple hello world container that is available in MCR. MCR stands for Microsoft Container Registry, which is public registry available with some sample containers. So we'll take our image from there. And then next, for each container, we should specify its consumption in terms of number of CPU and amount of memory. So for this container, it will require 0.24 CPU cores, and it will require 500 megabytes in order to run. Okay. And we'll go to enable ingress. That's default configuration. And yeah. We'll skip this part for binding, where you can make it connect to other services, and we go just to say review and create. And at this time here, Azure is reviewing the configuration of my container apps and tells me that here the configuration passed, so I can go to create the container apps. So the creation of Azure Container Apps will take about from 3 to 5 minutes. Okay, so that's going to be good time to get your questions if you have any.
I'll ask a question just to
Yeah.
use some time up. So for the attendees, I guess as well, the container apps is really, really nice. I like how it's takes away that AKS management. In fact, like in reality, when I'm working, I always ask, like, if people need containers, container apps is my first point of call, because you don't need all the management of AKS and things like that. What kind of workloads, what kind of scenarios do you see people using container apps for? Like in real world, is it they're hosting a payment processing application and they need to spin up a couple of microservices? What kind of things do you see people using container apps for?
Yeah. So container apps, let's say the key selling point or the main reason for which people will use it. It's going to be, let's say, the first choice for developers because it's easier for them to use. and because for them, they can own the service, they can own the resource. So in large organizations, typically you would have the developer team, what we call the project team, people who are the developers who write their code, and then they will deploy that application to the cloud. Okay, what will be deployed or the resource on the cloud is typically, it depends on the resource, but if it's infrastructure service like AKS, this means that here the team who will manage that cluster needs to be a team. So it's not one single person who will manage it. And they need lots of knowledge in terms of infrastructure. And this means that the developers cannot do that because they don't have enough. Typically, some of them they do, but most of them, they don't have enough knowledge to manage an AKS cluster. So we would have a second team that is the platform team or the ops team or the infrastructure team. Each organization names them differently. And the role of this other team is to manage the infrastructure for the developers. So this means that here the developers are not the owner of their resources in the cloud. And sometimes this creates like dependency between the two teams, because if you have a resource like AKS, which is not owned 100% by the developer team.
It's a shared service, right? It's something that usually in most organizations, AKS is quite large, so it's managed centrally, and then other teams consume it. So it's AKS enables more of a platform engineering perspective where the teams enable developers to use this in secure ways with like Azure policy and stuff, right?
Yeah, exactly that. So here there are two perspectives how to look at for AKS. So either some organizations will say just the AKS cluster will be created by the infrastructure team. They will configure it and then they will give it to the developers team. So the developers team will have access and they can do whatever they want, except some infrastructure operations like upgrading the cluster or adding or configuring the networking to choose the virtual network and so on, but they can do anything else. So the dev team owns their cluster. Some other organizations will say the cluster, as you said here, it will be a shared resource. So the cluster could be used by not only one single team, but by multiple teams. And here we talk about multi-tenant clusters, and those different teams, each team can have like its own namespace. They can deploy their own resources. They won't touch the resources from the other teams. And again, this is going to be the responsibility of the infrastructure team to make sure they deploy and they configure correctly the cluster to be used by those different teams.
I want to touch on something else very quickly as well, is like you talked about Envoy and Cada and Dapper. Those are almost third-party services consumed by container apps. And so not only is Microsoft managing the underlying infrastructure and the Kubernetes versions for you, but you're also managing the updates of all these other services as well automatically as part of the service, container app service offering as well. So as a consumer, you don't need to worry about it. It's always going to be up to date.
Yeah, exactly that. So to come back to your question originally, when people uses container apps versus AKS, you can see it in terms of resources. The different teams are responsible about different stuff, and you can see it also from another perspective, which is to ask what are the limitations of container apps versus AKS. So typically, what we say to our customers is just when you decide between container apps and AKS, your default choice should be container apps. Take a look at container apps at, let's say at 80%, 90% of the time it will satisfy your requirements. You can use it, okay? For the 10 to 20% use cases where container apps cannot do it because of a technical limitation, because, for example, in container apps, you cannot deploy your own logging tooling, for example. So for today, you are limited to use only container Azure Log Analytics in order to do that. We have today a work in progress where you can use other tools like Datadog or other third-party tools.
Yeah.
But at some time that was not possible. So for those technical limitations, then you move to AKS, which can do almost anything, and it's open to lots of platforms.
Okay, cool. I see the deployment's finished, so just wary of time,
yes.
but yeah.
Yeah, good. Our deployment is ready right now, so I can see what was created, and we see all of these resources created together. So we have the environment, the log analytics workspace, and the container apps. Let's take a look at these resources. So I can go here to the resource group to see again those same resources created. And from here, I start by taking a look at the Azure Container Apps environment, which is a collection or which will host the different container apps. If I scroll down here to apps, I can see my demo Azure Container Apps running here. If I click on there, I'll be able to see here an application URL, an FQDN for my container apps. If I click on that URL to open it in a new window, you can see here it's opening up on this web page. Okay, this is telling me that my application is running the hello world image. Remember that image that we configured during the creation of the container apps. Okay, so this is my container apps running on internet, exposed on internet, on public endpoint on this URL. Okay. So let's take a look at this configuration or at this container apps. So container app is composed of containers, and from here we can see that containers. So the container is coming from MCR, Azure Container Registry or Microsoft Container Registry, and the name of the image is Kubernetes SE/quick start, and it's deployed with the image tag that is latest. Okay. From container apps, we can auto scale. So when we created the container apps, the default auto scaling rule was between the minimum, which is 0 to maximum of 10 replica. Okay, of course, you can change this. You can go up to 1000 replica for your container. And this is per container apps. It means that if you have 3 container apps, you can go to 3000 containers. Cool. For container apps, we see here this option saying volumes. What is a volume? So for container apps here, we are deploying only the container. But for some use cases, you want to save data. You want to save files, Excel files, PDF files, or you want to save database file also. So for those use cases, you can use a volume to save this data, so it will be persisted. Because if you persist your data into container apps is ephemeral. The container is always ephemeral. When you lose it, you will lose all the data inside that container. So we never recommend saving data inside the container itself. So instead, you save it into a persistent volume like Azure File Share, for example. And that's the option that you can configure with volumes. If you say add here it will ask you whether you want to use Azure File Share, which is Azure File Volume, or ephemeral storage, and you configure it from here, and you attach file share from there. We have lots of other functions, lots of Azure features for container apps like authentication. So as you might have already seen with Azure App Service, you can configure an authentication page so that only people authenticated with Microsoft identity or with Twitter or with Gmail can access your applications. For the secrets section here, your application, there are some use cases where your app needs to access to an external database. To access the database, it will require the service or the server URL, and it will also require the database password. If your application is using a password, then you can write the password into the source code, but that is the worst practice to do ever. Never save passwords into the source code, because that will make your application as a security threat, and that could be exploited by bad guys that can extract that secret from there. So what is recommended is to save those passwords outside of your application. And where to save it? In this case, in Azure, we recommend using Azure Key Vault. Okay, Azure Key Vault is an Azure service where you can save your secret data, like that could be database password, that could be API token or API key for an external service, or it could also be a TLS certificate. It can also save files as secrets. And with this feature, secrets and container apps, you can connect your container apps to the Key Vault and retrieve the secrets by its name. So from here, as you can see, you can configure a Key Vault reference, and then you specify managed identity to authenticate to that Key Vault, and then you will be able to retrieve the secrets. Then your application can read that secret that will be available as an environment variable to your container. In terms of ingress, it means how you expose your application. So you can say here, I want to enable or disable ingress. Ingress enabled means that your application could be consumed from outside the container apps. And ingress disabled means that your application will not be exposed. This is the case for container app jobs, for example. When you run a job, you don't want to expose through a URL, for example, or for some specific use cases for backend services, for example, you don't need to expose it on the internet. It will be exposed only for the front end, which will be deployed into the same network as the backend. So you don't need to provide external access to that backend. So yeah, then you have lots of other configuration. Let's go now for custom domains. So the application that we have created earlier is available on this endpoint. Sorry, it's too small to see, but this is an FQDN that is composed of name of the container apps, then a random name, then name of the Azure region, Sweden Central, .azurecontainerapps.io. This URL is not okay for companies or for anyone who wants to use his custom domain name. And for that, you have custom domains here, this feature that will enable you to create and bind your own custom domain name. So you can tell container apps to generate a TLS certificate for you, or you can bring your own TLS certificate. And then you say from here, I want to use my domain name, like my company .com, for example. And then you bind it and you'll be able to use this URL instead of the one provided by default by container apps. And then here where you can configure Dapper, you can enable it, you can configure some advanced features in Dapper. And then we have here the within the identity section. So earlier we mentioned that if container apps wants to connect it to a Key Vault, it will use an identity. What is identity? So identity is used to authenticate to Azure services. So container apps might need to connect to other services like Key Vault, or like Azure Storage Account, if we are saving files there, or if you are using blob containers, it might require to connect to an external database like Azure SQL Server, Oracle database, whatever, MongoDB, Cosmos DB. So for these services, we can save that password. We can use connection based on a login and password. But for the container apps itself, we can skip this this mode of authentication and use a better and more secure authentication type, which uses the managed identity. So managed identity is yet another Azure resource that will enable container apps to connect to other Azure services, not using password, but using the identity, this managed identity itself. So when you create your resources, you say, hey, I want this container apps to be able to use this managed identity in order to authenticate to the Azure resource. So it makes authentication a lot easier. Thank you, Luke, for sharing the link here for the managed identities.
Yeah, we have a question in the chat.
Yeah.
The question is, can you integrate the volumes with a predefined share already active in your storage account? So I think this is going back to the storage.
In the predefined, yes. Actually, you should. That's the only option today. You should create the storage account, then create the file share, and then you can connect container apps to that file share. Container apps cannot file share automatically for you. It's not like with the AKS where you can say, I want to use this PV persistent volume of type file share, and then AKS will create the storage account for you and creates the file share for you. Here, no, you should create it first, provision it first, and then bind it to container apps. Okay, let's continue exploring the features. So here we have logs, which we have already presented, and but just let's see how this works from here. So within the logs, we can get the logs from the console logs. So if I click there, let's try to use this within the editor. So here I want to get the logs from within this table. So this is the table of the logs from Azure Log Analytics, which was configured automatically for this container apps. And here I can see a log coming from there saying that this application is the text of the log. So this should, yes, the log S, this is the content of the log. So telling that the application started and it's listening on port 80. Okay. We can also see the logs in live mode, live stream logs. So from here, we choose between console or system logs, and here we can see in real time the logs coming from container apps. Like with AKS, when we deploy a pod or a container, we can access to the shell or to the bash of that container. We can do the same with container apps because at the end it's container, and that container will be its bash will be available. No replica found. Oh yes, this is telling me that here no replica found to access to, because this means that there is no instance running. And why is that? Remember, because in the scaling we have configured 0 to 10. So at this time there is no traffic on my application. So container apps decided if there is no traffic, then I should scale down to 0 maybe. But if there will be a traffic, like what I will try to simulate here, if I reload the application, or if I try to revisit the application again, then this will generate a traffic. And note here, this request will take a little bit more time, because during this time, a new instance of container apps is being created within my environment. And yes, now it's created. So if I refresh again, yeah, now it's instant, because the instance is there. So if I go back here to where we can see the containers, maybe revisions. Yeah, here we can see one instance already running. Okay. So this means if I go to console now, I should get an instance running so I can access to that instance. To access it to the bean, so there is the shell or the bash, you can access whatever you want. I'll try with bash. And from here, I'm within my application. I can do pwd, I can do ls, and I can also do to write the environment variables. And this is interesting here because you will see some environment variables have the name Kubernetes service, Kubernetes port number, and so on. So this means that you will know when it will move out of Kubernetes when you don't see any environment variables for Kubernetes, maybe. So yeah, that's one feature. And yeah, that's almost all the features available within the container apps itself. Let's go back to the container apps environment, where here we see some different features, like here, the certificates. Okay, so for the certificates, if you want to use a custom domain name, you can upload a new certificate from here, or you can ask container apps to generate a certificate for you. And then when we created the container apps, during the creation, we have seen that we can choose a specific type of virtual machines, and you can choose different types of virtual machines. So you can mix and match between different types. So from here, we have the consumption that will be created by default, and we have the demo profile that we have chosen. Okay, and of course, at any time you can go to create a new profile and choose one of the profiles that are available right here. Okay, and it's actually from here where you can mount that Azure file share, where you can specify the name, the storage account name, the storage account key, and the name of the file share itself. And yeah, and oh, good surprise here. This is still new today, is the Open Telemetry endpoints. So this is a new feature in Azure Container Apps environment, freshly new, to support sending logs and metrics to different endpoints. Cool. So that's gonna be all for my demonstration. Let's see if you have any questions in the chat. Okay. Great.
Nothing so far, but I think you've been very thorough in your presentation. So thank you very much, and thank you for answering questions.
Thank you too. I'll share with you links for I'm running actually a YouTube channel and Udemy courses where I post courses about anything related to Azure and Azure DevOps and Kubernetes. So I have courses for how to use container apps, Azure DevOps, GitHub Actions, AKS clusters, and Terraform for the people who likes to manage infrastructure. So feel free to get there. I also publish typically lots of free coupons on LinkedIn. So follow me there, and you will get to my posts where you can get those coupons. I share the links with you on the chat.
Your courses are actually how I found you. Because I think I went through the container apps course actually. So yeah, really, really good.
Great, you did. Proud you did. Okay, I shared those links for you.
Yeah, any last questions, anyone? Feel free to come off mute or put it in the chat. Thank you, Houssem, again for coming and giving all your knowledge with us.
Sure,
definitely appreciated, especially taking the afternoon or evening to come and talk to us today.
Yeah, thank you too.
Lots of thanks in the chat. So, yep, that's good.
Thank
I'll
you,
stop the
everyone.
recording, but